Okay. Shh.
Yeah.
Okay, so we did things like this last week, right? We found the area bound between the curve and the axis. So this, remember we did this, and we also did an example that looked like this.
Yeah.
So this is when we're integrating with respect to x, and this is when we're integrating with respect to y. So if you're integrating with respect to x, you're finding the area between the curve and the x-axis. If you are integrating with respect to y, you are finding the area between the curve and the y-axis, right? So hopefully, again, I know half of you didn't even look at the video that I posted. I posted 2 videos for you, and both of them have 8 views.
Whoa.
There are 15 of you. And maybe there's someone who watched it twice, which means half of you didn't even watch the work I did for you. I don't make those videos for me. They're not for fun. They're to help you learn. The fact that you're not even bothering to access the learning is really, really disappointing. You have to be more responsible for your learning, okay? Thank you to the people that are doing the right thing. For the rest of you, you have to step it up. You're about to hit exam time. So what we're going to do today is make this slightly more difficult. I am going to find the area bound between 2 curves. It is not different to this though. If you know how to do this, then there's one little extra step. It's not really different. So if I have, let's make it a bit lower. So if I have, again, a curve like that, but I also have a straight line curve, and I want to know, so they're going to intersect at various points, right? So I'm going to say that this is coordinate 1 and this is 6. Okay, so this goes down to 6, this goes down to 1. I want to find the area bound between the curves. All right, so I'm going to say the equation of this line is y equals x plus 1, and the equation of the curved line is clearly a negative quadratic. So it's going to be negative x squared plus 8x minus 5. All right, so what I'm going to do now is I'm going to integrate. Now, I'm going to do exactly what we did last lesson, but I'm going to have to put these 2 things together instead of just doing one of them. All right, so let's move this over here a bit. So what I'm going to do is I want to find the integral between 6 and 1, right? Those are my 2 points of the top line. So I want negative x cubed minus 8x, sorry, plus 8x minus 5. I want that with respect to x. Gosh, I really don't have enough room for this. And I want to subtract the integral between 6 and 1 of x plus 1 with respect to x. Now, the good thing about this is I just do one thing minus the second one. You can just put them together and do it at once. So what I have is I've got negative x squared. So again, we're finding the integral between 6 and 1 of negative x squared plus 8x minus 5 minus x plus 1, all with respect to x. Now, this, you have to be really careful. This is where people mess it up. This negative distributes to both parts, right? You can't just take out the brackets and put them together. You are subtracting this, which means they both get a negative. So that means if I put them together, I've got negative x squared. How many x's do I have? 7. What's my number? Negative 6, because this is minus 5 and then minus 1. And I'm integrating that. Why do I keep saying that? I'm integrating this all with respect to x. All right, so what I need to do now is exactly what we did last week. So I am going to, first of all, integrate. So I have, what did you say? So I add a power, divide by the new power. Good. Okay. Okay, do we need plus c when we're doing definite integrals? No. We don't. We only use that when we're doing indefinite integrals. So again, I'm now integrating between 6 and 1. Oh, why am I doing that? Because I've already integrated. That was a stupid thing to write. Okay, so what I need to do now is just substitute in 6 and then minus, substitute in 1. So I've got negative 6 cubed over 3 plus 7 times 6 squared over 2 minus 6 times 6. And all of that is going to subtract negative 1 cubed over 3 plus 7 times 1 squared over 2 minus 6 times 1. And again, you can type all of that into your calculator. One of the concerns that I have is that some of you are using your calculators incorrectly. I did definitely see some people who had made some mistakes on your last test. Your working was all correct, but your answer was wrong, which means you're just typing it in wrong. So just be really careful when you're using your calculator. And if you type all of that in, you should have 20 and 5/6. And this is area, right? So it's units squared if they don't tell you anything else. Do you have a question?
If it was negative 6 squared, would it be negative 6 bracket square or 6 square and then negative?
Yeah, really good point. The brackets would be around the number. So if I have negative 6 squared, right? Because it's negative x squared. It's not negative x squared. Make sense? Yeah, so you would put the brackets around the number. That is correct. Yeah.
Can we integrate the two things first and then minus each other?
Yes, you can, but that is a lot more work.
Yeah,
You absolutely can do them separately and then just do it all, but that's more work, right? Because then you have to do 6 minus 1 of that minus 6 minus 1 of the other one, right? So it's twice as much work to do it that way, but yes, it does work.
With the things that we did yesterday with the lines, with the other lines as well.
That's the least articulate question you've ever asked. I don't know what you're asking. Say it again.
Yesterday with the questions like question 10.
Like question 10. No, because the problem is you're still bounded by the x-axis in that one. So in this one, we're not being bound by the axis, we're being bound by the 2 lines. So no, it doesn't work that way. All right, good question. Did everyone understand Josh's question? So he was asking, does that apply to what I set you in 9F? Like if you have a look at question 10, there are 2 curves intersecting. Can you do that with this? The answer is no, because that is bound by the axis, not by another curve. What we're doing here is finding the area between 2 curves, not between 2 curves that intersect with the axis. Okay, so no, you can't do this with yesterday's stuff. Okay, I'm going to do another example. Right, so I'm going to do exactly the same thing, but this time I'm going to make the shape upside down. Okay, so I'm going to, again, try and draw something. I'm going to do a positive quadratic this time, and I'm going to do a line that goes like this. Now, the interesting thing about this is I have some of the area below the axis and some of it above. We said we had problems with that last week. Do you think we're going to have problems with it this week?
Yes. Yeah. No.
Why not? Why is it different to last week?
We're not bounded by the x.
Yeah, good. So there was a problem last week because if we had stuff that looked like that and you wanted above and below, you end up with positive and negative problems. But with this one, because we're bounded by the lines themselves, not by the axis, it doesn't matter. So this stuff only matters when you're interested in the axis. It doesn't matter when you're interested in 2 different curves. Right, let's get rid of that. Okay, so let's write some equations. So this one is going to be y equals 2x minus 9. And the curvy one is a positive quadratic this time. So this is going to be y equals x squared minus 6x minus 2. All right, so we're going to do exactly the same thing. We are going to say one minus the other, and we're going to put them together as a single equation. So I want, or actually it might help if I give you some points. This is going to be 1. And this is going to be 7. So we are going to integrate between 7 and 1. And we're going to integrate the top line, right? So before we did the quadratic minus the linear one, but we're going to do it backwards because we always start with the one on top. So I've got 2x minus 9 with respect to x minus the integral between 7 and 1 of x squared minus 6x minus 2 with respect to x. Right, so let's put it all together. I'm going to change colors. All right, so this time I want to integrate between 7 and 1, and I've got 2x minus 9, and I have to subtract x squared minus 6x minus 2, or with respect to x. Now, this negative is going on all of my terms. So I'm going to integrate between 7 and 1. This becomes what? Negative x squared
Plus B.
plus 8x.
No, plus what, what's minus 9 plus 2?
You can do the hard bit and you can't do minus 9 plus 2. That's going to make me cry. All right.
Oh, yeah.
So we have negative 7, and all of that is with respect to x. All right, so let's integrate. What does this become? Negative x cubed over 3. Wow, that was a really long line. Why did I do that? Over 3 plus what?
4x.
I'm going to write it the long way, but you're right that it is 4x squared. Add a power and divide by the new power. 7x, and again, you divide by 1, but blah, blah, blah. All right, so then these two simplify. So I've got negative x cubed over 3 plus 4x squared minus 7x. Now I just put in 7 and 1, do my subtraction. So then I have negative 7 cubed over 3 plus 4 times 7 squared minus 7 times 7. All of that subtracts negative 1 cubed over 3 plus 4 times 1 squared minus 7 times 1. And if you type all of that correctly into a calculator, you should have 36 units squared. Yeah.
Why do you minus the 1 better?
Say that again, sorry.
Why do you minus the 9 better?
So what you're doing is you're taking the top line and then you're subtracting the bottom line, right? So this is the one on top minus the one on the bottom, but you can just put them together as a single thing. Are you asking why it's that way around and not the other way around? You just start with the one on top, right? So in the previous example, the quadratic was on the top because it was upside down, but in this occasion, the linear one is on the top.
Could you minus the quadratic by the 9 if the 9 was in respect to y?
If the line was in respect to y.
You're finding the line with respect to y, not x. Like the shape between.
You can totally do that if the whole thing is sideways and you're doing, they have to be both in respect to either x or y. You can't have one of each. We're not doing one of each. You have either they're both y or they're both x. Yeah. Okay, so this is exercise 9G. We are finding the area bound between two curves or two lines this time. Right, I'm going to save that. And I'm going to come around and have a look at your lovely work of 9E and F.